start. Sir, we are live.
Good afternoon, good afternoon, good afternoon, my dear friends. I'm Saurav Upadhyay and I welcome you all to the live quiz session on behalf of the Gate Academy. My dear friends, how are you? Is the audio video clear from my end? Have you guys joined? Do let me know. Is anyone present with me? Are there are there candidates with us? Do let me know in the comment section. Has anyone joined with us? I'm still waiting for the candidates to join with me so that we can have the live session of the quiz. My dear friends, yes. So let me tell you, my dear friends, I have been associated with the GATE Academy for the past 3+ years and I've guided many students in their journey towards their GATE preparation, my dear friends. My dear friends, what is the importance of such quiz sessions? Why are we here? Why are we having such sessions? It is only to benefit you. Now, how it can benefit you? Let me tell you in a very brief way. Whenever we practice questions, we generally forget that there is something called time constraint in the real exam scenario. But when we sit in the actual exam, there is a time limit. There is we always have in the back of our mind that there is a particular 2 minutes or a 3 minutes to solve this particular question, and only then we tend to commit even the silliest of mistakes. Even we 2 plus 2 we tend to write it as 3. So my dear friends, this is where such sessions are going to come handy. 30 minutes, 5-6 questions, you do it and you will be able to judge that whether you are able to solve questions in pressure or not. And I recommend you strongly to attend these sessions so that it will give a very good understanding that where in the exact scenario you lie, where is your preparation lying, right? Whenever there's a time constraint, we always tend to perform in a very little, you can perform better also. I'm not saying that it's always you will be going to commit mistakes. So this is where we have to see that how we are actually performing. 30 minutes. Now what I expect you is that sit with a pen paper, forget everything, pen, a rough paper, everything means just remove everything else. There is a timer, 30 minutes, 5 questions. Most of you are, I've already played before. Some of you are new. In case some of you are new, I'll be explaining you all the rules associated. Do not worry about that. Now, my dear students, I'll be explaining you the rules, not that. What I want to say is that I've selected questions from maths. You can see that over the chapters I've selected from different topics. Now, there is a probability question, there is a, vector calculus questions and so on. Now, my dear friends, what are the instructions? Before I tell you the instructions, you can see over here that there is a bit.ly link. Now see, you have to open 2 tabs, one PC and one mobile. One PC, one mobile. 2 tabs needs to open. In one tab, you are seeing me interacting with you, telling you, talking with you, and in the other you need to play the quiz. Now the other tab, you need to write this bit.ly link, red color bit.ly link that you are seeing on the screen, my dear friends. Here is the bit.ly link, bit.ly/tga078e. This is the link that you need to type on your tab, and this is where from you can join with us in the quiz session. My dear friends, I'm again saying how to join. This is a bit.ly link. You need to type this red color link in a separate tab, and in a separate tab you will be able to see me, where we can talk. What are the instructions? The instructions are no negative points are there. That's the best part. No negative points are there. You need to answer every question. Yes, there is some disturbance over here. I can already, train is passing from here, so don't worry about that. No negative points are there. Now, for every question, there is a stipulated amount of points that will be displayed on the screen, and tougher the question, more the points. You know, that's the sense. Tougher the question, more the points. Faster you answer, higher you score. Yes, there is a particular amount of time that I have put for any question that a standard student should take in order to solve the question. Now, even in that, let's say I have allotted 2 minutes for you to solve this question. If you answer that question in, you know, in 1 minute, more points will be able to, you know, gain. So these are some common points which most of us are have known. So my dear friends, whenever you are ready or have joined, you know, many have joined over here, I can already see. Just write, yes sir, we are ready. Just write ready sir from in the comment section, and I'll be just, you know, presenting you the question in front of you. Just write yes sir or whatever. Just give me a, you know, indication that yes sir, we are ready. You can start the session. So students, are we ready? Tell me, are we ready to start the session? You know, I'm not able to see the comment section. Yes. So some names I can see: Gaurav, Vikas, Vamsi. I think I have, you know, has played before also. Maths, Mohammed Tanveer. Okay. I'm waiting. You know, this is why I am not starting the session right now. So are we ready, Mohammed Tanveer? Join fast in that bit.ly link that you are seeing on the screen, and we means you'll be starting the session in less than, you know, 30 seconds. So what I've told, rough paper, a pen, that's it. 5 questions will be there. You have to solve those questions, right? In as less time as possible. You know, that's the sense, as less time as possible. So I'm starting this session, my dear friends. I'm starting the session. Just a minute. So nice, you know, emojis you guys have selected. You know, Tanveer, I can see. Siva, I can see. Mohammed Kaf, I can see. Ambati, I can see. You know, these are some really nice emojis that you guys have selected for you, and these are really cool. Avilesh. Okay, fine. So I think guys have joined. I'm starting the quiz, my dear friends. The first question in front of you. Yes, the first question, my dear friends. You can already see the questions in front of you. 1.5 minutes has been allotted for this question. 1.5 minutes has been allotted for this question, my dear friends. I won't be saying anything in this time. It's a question of vector calculus. MCQ question. Directional derivative of f at the point this becomes maximum in the direction of what? In the direction of what? Less than 30 seconds remaining, my dear friends. Less than 30 seconds remaining. Let me tell you, no negative points are there. So try your luck. You know, most of us have the tendency of, you know, taking anything. Try your luck. Answer everything. Answer at least answer. 3, 2, 1. Time's up, and let me see. Okay, my dear friends, I'll be telling you 6 students have given the correct answer. 6 students have given the correct answer. 6, 2, 8 plus 1, 9. Okay, fine. Let me tell you before we go on to the, you know, leaderboard. Let me tell you that the leaderboard can change at any instant of time, and Blesson has, you know, is number 1 candidate. Second is Nikita. Third is Siva. and Mohammed Kaf. So I can see that not much difference is there between the guys, and the table can turn at any time. This is the beauty of the quiz session. The table can turn at any moment of time. So answer something. Yes, that's what I want to say. Answer something. Answer something. Now here's the second question that I'm going to present, my dear friends, in front of you. Take a deep breath. Take a deep breath and take a deep breath. Here's the second question, my dear friends. So as I said, I've selected the questions from all, over the engineering maths domain. So it's a question of numerical methods. Newton-Raphson method, one of the most important method that, you can expect questions from in GATE. The iterative relation to solve x equal to sin x using Newton-Raphson method is what? Newton-Raphson method. Newton-Raphson method, my dear friends. Newton-Raphson method. 15 seconds remaining, 15 seconds in case. I'll tell you what. Answer something. Answer. No negative marks are there. Answer something. 5 seconds. 4, 3, 2. My reference time is already up. So 5 students have given the correct answer. You can see already that 5 students have given the correct answer only. Yes, I need to say only. And what's the leaderboard? Okay, Blesson, he has maintained his top spot. Second, the second position has changed. Siva has, come second. Third is Mohammed and Avilesh, then Ambati. These are the top candidates that I can see on the screen. Nikita. So Blesson, very good going, very good going. It's very impressive. Now, my dear friends, before I give you the third question, let me tell you that more the students, more will be the fun. So these are absolutely free sessions. Share the session with your students, with your friends. They will also come. They will also get to know how their preparation is going on, and it will be fun. More the students, more will be the fun. Yes. So share it with your friends, right? So I'm going to present you the next question, right? And here is the next question, my dear friends, on your screen. Okay, so it's the, line integral question. Now, my dear friends, one thing I'll tell you, there is a slight printing mistake, my dear friends, from our part. That R you are seeing over there, integral V dot dr, that is not R, that is actually over the path. Yes, a slight mistake is there, but that's very fine. No issue. Over the path. That's not R, that's over the path shown in the figure. Over the path shown in the figure. So it's a line integral question. Very, very important. All the important topics of GATE, I have I've selected the questions and brought in front of you. All the important questions. So less than a minute remaining, If V is given as this, integral V dot dr over the path shown in the figure is what? Do like the session in case you find it useful. Yes, those are the basic things that anyone would say. Okay, less than 10 seconds, 5 seconds. Answer something, answer something. Let me see. Okay, so my dear friends, uh, only 2 students have given the correct answer. Only 2 students have given the correct answer. So, well, that's not a very, good thing. But anyway, let me check the leaderboard. And my dear friends, Blesson, Blesson, very good going. Blesson, very good going. Very good going. Abhilesh is not far. He's also doing good. After that, I think the gap is increasing between from third to downwards. Siva, Mohammed, Kaif, Ambati. But I think it's between Blesson and Abhilesh from here onwards. I think so. I think so. So very good going, both of you. And I'll be waiting for 10 seconds. Yes, I'll be waiting for 10 seconds. I'm not going to throw, questions after questions after questions in front of you. So take paper, pen, change change the paper, everything. Have some water. Have some water. Take a deep breath. Yes. Fine. Fine. Let me give you the next question now. Let me give you the next question now. Here is the next question, my dear friends. It's a probability density function question. Probability PDF. That's the beauty of the session that we are having. Now you can argue that, sir, we haven't studied, or it's the questions are on the difficult side, but it's a very standard questions that I've given you, my dear friends. It's a very standard questions. If the basics are clear, you will be doing good. No, no doubt in that. If you are thorough with the basics, you are going to do good. Okay, it's an MSQ question. MSQ question. Yes, let me tell you, my dear friends, MSQ questions, one or more options may be correct, right? So, pay very, special, you need to be focused over here. One or more options may be correct. 7 people have already answered, and I've increased the time. I can also see that, yes, I have increased the time for such questions. So time has been sufficient, I guess, and 10 people have already answered. So it's very, good signs these are. So 40 seconds remaining, my dear friends. If you like the session, do drop a thumbs up and share it with your friends, my dear friends. 18 seconds, 15 seconds remaining, my dear friends. At least answer something. At least answer something. Five seconds. 4, 3, 2, and 1. Time's up. Time's up. Time's up. Okay. 6, 6, 6. Okay. So here it's very difficult to say that how many of you will get full marks for this question. But anyway, the leaderboard will tell us what's the scenario. And I guess Blesson has been rocking today. Blesson has been rocking today. Absolutely stunning. Very good. Very good. Very good, Blesson. Very good. And the second, Abhilesh, Ambati, Nikita. Nikita has, jumped up. Abhilesh, Ambati, Nikita. Siva has gone down. Mohammed Kaf has gone down. So, Blesson has done excellent, excellent. So anyway, we are here for the next question, and I think it's the last question, I guess. Yes, it's the last question, my dear friends. Do give it a try. Try to do it correctly. That's the most important thing. Try to do it correctly. Read the question nicely. Read the question nicely. Read the question nicely. The amount of time a repairman needs to fix a washing machine is uniformly distributed between 1.5 and 4 hours. It's a question of uniformly distributed functions. Uniformly distributed function. Let x equal to time needed to fix a washing machine. The probability that a randomly selected machine requires more than 2 hours is what? NAT type question. One decimal place. NAT type of question, one decimal place. So less than 30 seconds remaining. Now I expect you people to answer this correctly. Yes, I expect you people. This I have put on the slightly lower side of the difficulty level. So 8 seconds remaining, 7 seconds remaining, my dear friends. I hope you people have answered. So, okay, only two people have answered it. Only two people have answered it correctly. And let me see what's the leaderboard. And as expected, Blesson has been absolutely rocking today. Many congratulations to Blesson, who has done excellent. Many, and let me see what's the situation. Ambati is second, Avilesh is third, fourth is Nikita, and then fifth is Siva, Mohammed Kaf, Vamsi, Bhagyashri, Sanvi, Blaze, and Tanvir. Okay, so Blesson, what's your good name? You can tell me if you are listening to me. You can tell me on the comment section, Blesson. So my dear friends, what I will do now is that I'll be discussing with you the solutions of these questions, and there only you will get to know that where exactly did you lack, why weren't you able to solve the all the questions correctly. So you'll be able to know only there, right? So well done to the people who have attended the session. Just a minute. So my dear friends, what I will do is that I will discuss with you the solutions of these questions, right? This was the first question, my dear friends. The directional derivative of fx given at the point 111 becomes maximum in the direction of what? My dear friends, directional derivative becomes maximum. Can anyone tell me becomes maximum? What do we need to find over here? Can anyone tell me in the comment section that what do we need to find over here, or what exactly you guys have found out in this question before I proceed with the solution? My dear friends, the directional derivative becomes maximum in the direction of gradient. The direction derivative becomes maximum in the direction of gradient, my dear friends. So here you need to find what? You need to find grad of f. Grad of f is shown as this thing. What is the formula? Del f by del x I cap plus del f by del y into j cap plus del f by del z into k cap. Yes, this is the formula, my dear friends. So what is f? Your f is given as x square minus 3yz. X square minus 3yz. So let us quickly solve it. You know, if you solve it, it will be 2xi minus, it will be minus 3z. These are partial derivatives. Plus, not plus, again it will be minus 3y k cap. And at what point it has been asked? 111. So if you put the data, it will be 2i minus 3j minus 3k. So what is the answer? I guess the people who have given its answer C. The second question, what is the second question? The second question is telling you, x equal to sine x has been there. It has been given as the function, and you have to find the iterative relation using Newton-Raphson method. Using Newton-Raphson method. So what is Newton-Raphson method, my dear friends? What is the iterative relation for Newton-Raphson method? First of all, what is the function given? It is x minus sine x is equal to 0. So you can easily take fx as x minus sine x. So what is, Newton-Raphson formula? Xn plus 1 is equal to xn minus f of x divided by f dash x. This is the iterative formula for Newton-Raphson. So I'm only going to put the value, right? In place of, it is xn minus what is f of x? It is x minus sine of x divided by what will be f dash x. F dash x, f dash x, we need to find what will be f dash x. 1 minus cos of x. So just put it over here, 1 minus cos of x. So it will be what? If you just simplify it, it will be minus, n, I have missed n over here, minus x plus sine of xn divided by 1 minus cos of xn. Again, I'm missing this n. It's not a problem. So it will be sine of xn minus xn into cos of xn divided by 1 minus cos of xn. So once you put in the formula, you will get the answer. And what I'm getting option A as the correct answer, right? Only logic is what? You need to know the iterative formula and put the value of fx and f dash x over there. This was the third question, my dear friends, a line integral question. And I told you that this is over. This is what? Over the path shown in the figure below. The vector function has been given and you need to find integral v dot dr, right? So how to do it? How to do it? How to do it? My dear friends, line integral is nothing but what? I can write v dot dr. So v1 dx, dr is what? Dr is dxi plus dyz dyj. So v1 dx plus v2 dy, right? What is v? V is what? Yi plus x square j, right? This is v, yi plus x square j. So let me write it over here, y dx plus x square into dy. Now it's a closed loop, my dear friends. It's a closed loop. So whenever line integral question, closed loop is there, what we apply? Green's theorem. What we apply? Green's theorem. So using Green's theorem, what we can write? Double integral over the region. It is del of v2 by del of x minus del of v1 minus del of y into dx into dy, right? This is what Green's theorem. And if I simply remove this r, put the limits, if I only put the limits, it will be 1 to 2 for x and 1 to 4 for y. So you have to solve this double integral question, my dear friends. 1 to 4, 1 to 2, and del v2. V2 is what? This is v2 x square. This is v1. This is v2. This is v1. So it will be 2x minus 1 into dx into dy. This double integral you need to solve. This double integral you need to solve using what? This is what? Green's theorem. What is Green's theorem? It helps us convert line integral to double integral for a closed region. Yes, the region that you are seeing on the screen, the figure that you are seeing, it's a closed one. That is why we're able to apply Green's theorem. It's not that, for any line integral question, we'll be applying this Green's theorem. So it is what? X square minus what? X. First I am going to integrate using x. So 1 to 2, it is dy. Again, if you just put the values, it will be 4 minus 2 minus 1 minus 1. Again, it becomes what? 2 integral 1 to 4 dy. Again, from here it becomes very easy. 2 into 3, and the answer is 6 units. The answer is what? 6 units. The answer is 6 units, right? Answer C. Now again, coming to the next question, probability density function. I told you it's very, very important. You can almost expect one PDF question in GATE every year, irrespective of the branch. It's going to come. It's that much importance, right? So my dear friends, this was the question. The PDF function was given as, what was the PDF function? The PDF function was given as x square into e to the power minus e to the power minus mod x, right? So what is expectation? Expectation is nothing but, now since no limit has been given, it will be minus infinite to infinite x into fx dx. This is the meaning of expectation. Expectation means what? Mean. Expectation of x is what? Weighted mean. On an average, what do we expect? This is called expectation, right? Now we are not teaching over here, but I'm just saying you the brief. What is the meaning of expectation? The mean, average, the weighted mean. Fine. So my dear friends, I'm just going to put the values minus infinite to infinite. What is fx? X square. So this will make x cube e to the power minus mod x into dx. Now my dear friends, tell me one thing. Definite integral properties, we have learned that whenever there is an integral from minus a to a, minus a to a, minus a to a, what is the first thing that we do? The first thing that we do is check whether the function or whether the integrand is odd or even, right? So when you will be checking that whether this integral or this integrand is odd or even, we are going to substitute minus x over here. X cube will become minus, and mod x, my dear friends, mod x is an even function. Mod x is an even function. So e raised to minus of, it will remain the same. So it is what? Minus of fx, minus of fx. It's an odd function. F of minus x is equal to minus of fx. It's an odd function. Therefore, expectation has become 0. Expectation has become 0. Fine. The second option is saying expectation of x square. The second option is saying expectation of x square, right? So expectation of x was what? X into fx dx. Expectation of x square will be what? Integral x square into dx. Expectation of x cube will be what? Integral of x cube into dx, right? So minus infinite to infinite, x square will, which will make it x to the power 4 e to the power minus a mod x into dx. Now my dear friends, you can just see the function and guess that, sir, it's an even function. Sir, it's an even function, right? So if it's an even function, I can simply write 2 times 0 to infinite. Tell me one thing, from 0 to infinite, what will be mod x? Mod x will be x. Mod x will be x from 0 to infinite, right? So it will be e raised to minus x. I'm removing the mod sign. X to the power, this 4, I can write 5 minus 1 dx. This 4, I can write 5 minus 1 dx, right? Everyone agrees with me. Now, how do I solve it? How do I solve it from here? I have two options. One, use by parts method, eyelet method, which will be a bit long. Second, I can use gamma method of solving the integral. And when you will use gamma method of solving the integral, this entire expression, what you can write gamma of 5 divided by 1 to the power 5. It's a formula. What formula have I used? Of gamma function. Gamma function. Well, let me write the formula over here. 0 to infinite e raised to minus kx x raised to n minus 1 dx is equal to gamma of n divided by 1 to the power n. Sorry, k to the power n. This is the formula that I've used, gamma function. And once you solve using gamma function, you know, it will be 2 into what is 5? Gamma 5 is make 1 less, factorial. 4 factorial. 4 factorial is 24. 24 into 2 is 48. So my dear friends, you can see that e to the power x, expectation of x square will be what? 48. Now, variance was also asked. Variance was also asked. Now, what is variance? What is variance? Variance formula, my dear friends, there is only one formula for variance. What is that formula? E of x square minus E of x whole square. So my dear friends, this becomes 0 because E of x is 0. So we are left with only E of x square, and E of x square we have already calculated. This is 48, my dear friends, 48. So here, my dear friends, A, B, C, all the options, no, not all, D is not correct. A, B, C is correct. And I hope that, you know, the people have marked these three as your correct options. And my dear friends, we are into the last question, and it's a uniformly distributed function. What is uniformly distributed function? Between the range for any value of x, we are going to have the same probability. Between the given range for any value of x, we are going to have the same probability. So what I do, I simply draw a rough sketch over here, write it over x, write it over, you know, fx, the pdf, y-axis is the pdf, mind it. So what's the range given? The range given is 1.5 to 4. 1.5 to 4, mark here 1.5, mark here 4. Between these two, 1.5 and 4, we are going to have the same probability. We are going to have the same probability. Now from the sketch also you are seeing, that yes sir, everywhere we are having the same probability. Very good sir. So what will be the PDF function? What is the PDF function in for uniformly distributed function? 1 by b minus a. Very good sir. So you can see now that it's a constant. The PDF function over here is a constant. So yes, we are going to get constant only. 1 divided by 4 minus 1.5. What it will be? It will be 1 by 2.5. If you solve it, you will get 0.4. So it's a constant only, right? Fx is 0.4. So what is the question? The question is the probability that a randomly select machine requires more than 2 hours. More than 2 hours. My dear friends, more than 2 hours. What is the last limit of probability? 4 hours. It is saying more than 2 hours. That means the limit will be what? 2 to 4. What will be the limit? 2 to 4. So we have got fx, everything we know. So I'm simply going to put the value, my dear friends. It will be 2 to 4 fx into dx, right? We are going to find the probability. What is fx? Fx is 0.4. Fx is 0.4 dx, my dear friends. 0.4. 4 minus 2, and it will be 0.4 into 2. It is going to be 0.8. So my dear friends, it was a NAT type of question. So people who have given their answers between 0.7 to 0.9 will get their answers correct. No, I've put, you know, 0.1 range I have given. So these were the solutions, my dear friends. I hope that the questions were clear. The explanations were clear, and I'll be coming with more such quiz sessions after some time. So if you like the session, do drop a thumbs up. If you find it useful, do share it with your friends. They will also come. They will also, you and your friend will play the quiz session. You both can access your own preparation, right? So share it if you find useful. Fine. So all the best. Take care of your health. Do attend such sessions. Such sessions can prove to be very crucial for any competitive exam in general. My dear friends, it's time to sign off. We'll meet again. All the best for your preparation, my dear friends. All the very best. So I'm ending the session. Very goodbye.